YouTube user Roger Sale noticed something about the user event singleton tutorial that might be interesting to talk about. To quickly recap, there's a user event that is returned from all instances of this sub-VI singleton. It is used to generate a user event in the top half, which is then supposed to be handled in the bottom half of this block diagram. If everything works as expected, then this message control will display a message, and after that has been dismissed, then a message will be displayed from the second control. So if I press play, I will get the first message, and then there's a user event generated, and that will trigger the second message. Now, if I delete this message control and run the VI again, you will notice that it starts running, but nothing happens. The VI will actually get stuck waiting at the event structure for an event that will never arrive. As you might realize, it's because we now have a race condition in the diagram. I will stop this and then I will click on Highlight Execution and then run this again. As you can see, the top half of the diagram ran its complete course before the bottom half has even started. So when the execution of the bottom half has finally reached the event structure, the generated user event in the top half has already been lost. Now, if I open the user event singleton, and in the block diagram, I'll right click and go to the timing palette and choose wait. I'm going to make the VI wait 100 milliseconds during the creation of the user event. I will save and then go back to the main VI and turn off highlight execution and run again. Then the event is triggered this time, but of course the question is why. I will highlight execution once more and run again. As you can see now, for some reason LabVIEW starts execution at the bottom half, and it will reach the event structure in good time before the user event is generated. For some reason, the LabVIEW compiler finds it more convenient to initiate execution at the bottom half this time, and not just on occasion, but every time this particular VI is executed. Of course, when you have independent parts that still rely on each other, you want to make sure that all race conditions are eliminated. If you are using this kind of setup, then you probably don't want to use a user event anyway. You might want to instead use notifiers. First of all, notifiers can be named, so there's no need to use any singleton. Furthermore, notifiers maintain a history of notifications, so when you use the wait on notification function, you can decide to either include previous notifications or ignore them. Now, if I run this VI, then I will get an event-triggered message. Now it's time to highlight execution once more. As you can see, once more the top half of the block diagram completes its execution before the bottom half begins, meaning that a notification is sent before there's any function waiting on that notification. But since notifications are stored, that is no longer a problem. Or if you want even stricter synchronization between the tasks, then you might want to consider using rendezvous. Then both tasks are forced to wait on each other before either can continue. So, in conclusion, if you suspect that you have a possible race condition, then you should use either notifiers or rendezvous. Thank you for watching.